basically we wanted to talk a little bit about the components of the cooling tower, and we're going to start from the top of the tower through the tower and talk about the construction and the improvements that are out there that can save water, create efficiency, and just make the equipment a lot better and more efficient. But basically, in the beginning of the cooling tower, on the very top is the mist eliminators. And there's been an evolution, from the old galvanized style eliminators that basically that you see in a lot of towers and a lot of buildings, which are rusted, and you see really decayed units like this here. But that's the old technology, very coarse, losing a lot of water, basically drift coming out of the towers, circulating into the environment, wetting down everything in the environment, rusting it. Obviously, chemical drift comes with that. So that was one of the curious ones that I saw in Seattle. So we've evolved from that to the PVC eliminators, which you've seen those out there for a lot of years. Really lightweight units that fall off of the units, and you power wash them and they break apart. They're inexpensive, but they're rather coarse, and they're something you have to replace quite a bit. Well, there's been an evolution now to a new style, high efficiency drift eliminator. And what you do there is basically come up with, these are some new towers on the right. On the left is a retrofit that we did that is available for almost any tower, where you take the PVC mist eliminator that has more changes of directions and sharp edges in it to strip the water that's coming through here. You also create a tight pack that's got a perimeter collar to basically keep it tight, keep it efficient, to try to keep as much drift coming out of that as possible. So then you eliminate the problems that we talked about previously. One benefit is that we've seen where you have towers up against glass windows and you see all the sweating going on. Just the upgrade to these type of kits will cut that down visibly, and we've had quite a bit of success out there. So it saves water, improves the environment, also keeps the drift from coming in and exposing and deteriorating the outside of your cooling towers. So that gets pulled back into mechanical systems and just deteriorates fan housing, shafts, and things of that nature. So go ahead and move forward. The next step down from these is the spray distribution system. And in the old days, you had basically small nozzles and many nozzles that are spraying across your fill pack or your foils. Here's an example of an older VAC. This is in Seattle downtown, one of the high rises. This tower had 1,400 nozzles that we had to replace for them. The benefit to the newest designs, as you can see, these plug very easily. That's the pipe on some of these systems that plugs with debris. The nozzles are a high maintenance item. These are more of the 70s, early 80s towers. Then they've evolved into more of a standard nozzle, which is similar to these. I have some of these on the table you can see. So there's many different configurations and manufacturers that make these different nozzles. But since this has happened, we've had an evolution into a zero maintenance nozzle. And the zero maintenance nozzle is shown here in these pictures, where you can actually pass a 1-inch ball. And this is an example of the old nozzles and the new nozzle. These nozzles will pass a 1-inch ball. Basically nothing will plug in there unless someone put something like garbage bags or something in there. It's the only way you're going to get something into that. It oscillates the spray, creating more of a wet water disbursement over the fill media that eliminates the dry spots that you have in your fill media, which we'll be talking about in a second. So the more water you get over the fill, the more efficient, or your coil, the more efficient your heat transfer is going to be. Plus, less maintenance, obviously, and less plug nozzles means more efficient cooling. So that's an example of what we have here. There's also, for coil products, you have the zero maintenance nozzle, which is also passes a 1-inch ball. The water just comes down here and splashes out. Very good for fluid coolers and ammonia condensers, things of that nature. Okay. Now we're going to basically go below the spray distribution system to the fill media. Fill media in an open tower has basically evolved. This is a new style material that we have. It's a honeycomb design, basically trying to slow that water down as the air passes so you get better and greater heat transfer. And this has been an evolution from the previous sheet fill that was out for the years before this was developed. There's some earlier sheet fill that was basically laying in there at an angle like pages of a magazine, water running down it, air coming back up the other way. And basically it breaks down, it becomes brittle. It doesn't slow the water down as much as the new fill does. So you have a greater chance for heat transfer with this new fill. All the new towers have this design. Older towers can be retrofitted. You can take the old sheet fill out and put kits in. They're very inexpensive because anytime you're dealing with PVC, you know, it's a lot cheaper than some other materials. So these kits are available. This is for a counterflow tower. Here's a crossflow tower, which is more like the BAC design, where you have the fill at an angle, induced draft, air coming through, water coming down. So there's a couple different designs, but this was done originally in sheet fill too, and now there's these bundled kits with this block fill. So the other thing I want to say about fill media is that it basically gets dirty, gets scaled, and you start having plugged areas of your tower. There's some areas in the state where we cut this fill out with chainsaws, and it takes 2 people to lift it out. You see how light this is right now? It can scale that badly in some areas, and that's all, you know, pertinent to how well you do with your water treatment as well. But it does happen. It's out of sight. You don't know the inefficiency that you've created. So I recommend to people to look at replacing their fill, you know, look 10 to 15 years, you know, depending on the water treatment in the area. At least have it inspected. Okay. All right, let's move on. Fluid coolers, you know, I'll mention this for a little bit. With fluid coolers, one of the big innovations that's come out is the elliptical tube. The elliptical tube is basically that shape and design. The benefit of that is you get more surface area, wetted surface, which will basically save you, give you more heat transfer with the same water. On that last drawing, I think she just, right here, you can see the elliptical tube versus the traditional tube. And with a conversion, you can actually replace old coils with the new elliptical unit and gain capacity because you're able to get tighter spacing and more tubes in the same footprint. So that's a great benefit to this design. So there's just an example of the old and new. Also, next slide. Yes. Also, there's dry coils with fins basically around the tubes themselves to give you dry cooling. And you'll see that more and more coming in the future years, basically trying to be more water conservative with the eco coolers that are coming out, where you can run dry certain times of the year versus wet and save water. So that's a new push to go that way. So these I don't have one of the tubes here today, but they'll actually have a fin across of them, across this coil, and it actually do more dry cooling without water. So you'll see that coming in the future. It's available now because there's not that many of the units out there. Okay, mechanical drive systems. So obviously, we've worked our way down into the lower section of the tower. With mechanical drive systems, you know, there's obviously concern of the maintenance, the regular maintenance for these units. But one of the things that I'd like to talk about, without getting specific into maintenance of them, is the concern I have with drift and water level affecting those drive systems. The towers that have bad drift coming out of the top of the tower, or excessive drift, it gets sucked back in through the forced fan units and basically corrodes fan housing shafts. And I really recommend that people should look at their equipment, and especially when it's new, coat the shafts with some type of urethane product to keep it from blistering, and just, you know, pay attention for maintenance. Here's one fan housing and drive system that you can see in a fan shaft over here that are heavily corroded. This tower had improper water level control, and they were getting water into the snouts, and just all day long that water's going wet, dry, wet, dry, wet, dry, just eating the sheet metal surfaces apart, plus leaking out the tower, creating leaks. And so often we'll see the leaks underneath fan housings, and it's basically because they're operating their water levels too high. And we'll talk about level controls because that's one of the greatest items of waste also with water. With level controls, we have the traditional level control like a mechanical float here and typical valve. I don't have pictures up there, but these are mechanical float that are adjusted and work with like a toilet, you know, float, and trying to maintain your water level. The concern about this is obviously you can get out of adjustment. It's out of sight, out of mind. It's inside the tower. You know, people will notice that the tower's overflowing unless they're actually checking on it. So we've come and we've evolved from this unit to more of the electronic style level controls like here. with probes. And then we've had future evolutions from this to newer systems that have sight glasses and actually allow you to tie into your building automation system versus just a little gray box that has an indicator light. You know, troubleshooting is difficult. If you make it easy for the maintenance guys to see what's happening and have indicating lights to show it's alarming, if it's high level, low level, to tie into your building automation, you're just going to do a better job of controlling your water loss. Here's some slides of some retrofits with the newer style electronic level control. You open up the door, you can see all the functions, you can test the valve, you can basically sequence of the operation and test everything right from a control panel rather than some gray box or mechanical flow. The sight glass is a nice touch also. Anything else? Go ahead.
So, could you give me your top 2 or 3 ways to maximize the energy efficiency of the cooling tower?
On a cooling tower, energy or water conservation?
Well, actually, I'd love to hear both.
Okay. Proper spray distribution over this fill is probably the biggest thing, is that water is basically spraying over this fill material. Having good fill that's cleaned periodically and inspected, having a spray system you can trust. And we talked about the upgraded nozzle kits that are available as retrofits for even the older towers. You can put these new, you can buy kits, and all this stuff being plastic materials is relatively inexpensive for the energy you're wasting. So we talked about being out of sight, out of mind. You got this box up there and you got water running through it, but how do you know if it's working well or not? With the newer towers, you can look underneath it. You know, where I was just talking about the big access storage, you can look up and see the spray coming out through the fill. In some towers, you'll see spots where you have water and some areas that you don't have water. And that's not good. You want to have consistent flow across there as possible because you're wetting more surface area. If you got a bad nozzle and it's jetting down, well, you're not getting the water distributed over the fill like you would like to have it. So, you know, it's just common sense. You've got air flowing through here, you've got water going down. The more surface area you can get, the more energy you're going to save, the more delta T you're going to get in heat transfer. So your water's going to come out of the tower cooler, your chiller's going to see that, your chiller's going to say thank you and back off on the amps. So, and it makes a big difference because it just adds up. It adds up every day, every hour. Any other questions?